Hello, can you hear me? Hello.
Yes, I can hear you.
Okay, so how are you?
Fine.
Okay, so I hope you already get for our second days and third days material, and you also try to practice this type of mapping, how we can easily do. Okay, so basically today's session, I will try to
Yeah.
discuss about
Only,
some advanced
only
topic.
digitalization
Okay,
is only digitalization. For the next, we'll do it after. We
uh,
will maybe, yeah, I will just, yeah,
okay, no problem. When you face any
we just
problem,
repeat.
you can simply just you can show me the problem. Just you can simply share your screen and then show me the problem. Okay, then I also try to find it from your side and then try to give you the solution about that. Okay.
Okay.
Okay, so first of all, we try to complete our today's session, then talk about the problem solving. Okay.
Okay.
Okay, so just I simply share my screen.
You will show. Yeah, okay. Yeah, I'm talking for me. I just take notes.
Yes. Okay, so now can you see my screen? Is it visible?
Yeah, for my side, I just take note of. Yes, yes,
Okay, so now can you see my screen? Yeah.
yes, of course.
Okay, so let's go. Okay, so basically this is our
Yeah, yes.
total 20 days online training program, and we already cover our first day, second day, third day, and today is our fourth number of class. Okay, so basically we try to complete all of this course content one by one, and also try to discuss about the some practical example for different types of mapping. So today we will start from our remote sensing topic. Okay, so mainly how we can easily analyze the different types of remotely sensed data. Okay, so basically remotely sensed data, there are a lot of satellite images we can easily access from freely and use it this type of satellite images. So I hope you can easily learn all of those things for the remote sensing technique for the get the different types of remote sensing special geospatial analysis. Okay, so just a simple open my slide, and we will start from the stress level and then up to the advanced all of those level one by one. So let's go about that. So first of all, I will try to discuss about the some basic concept of remote sensing. So mainly how it will be work and how we can easily use the different types of band combinations. So a lot of things I will try to cover for the basic remote sensing. So first of all, what is remote sensing? Okay, so mainly remote sensing is a uh, technique. Okay, so mainly remote sensing is the process or technique to detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted and radiation at the distance. It can be satellite or aircraft or drone image. So special cameras collect remotely sensed image which help to researchers sense things about the earth. So mainly it's a technique from obtaining the physical properties of an area without physical touch. Okay, suppose I want to observe anything, but I did not visit the physically. Suppose you want to identify for the forest cover map for the whole country boundary of Bangladesh. In this time, it's not possible. You just go to the field and all of time, all of the place in Bangladesh and get the data. But when you want to use the remote sensing, mainly this remote sensing, it's obtaining the physical properties. It can be different types of vegetation cover, land use and cover classification, anything, any physical properties. You can easily extract the information without physical touch. Okay, you did not go to the physically this region, and using the remote sensing user to capture, visualize and analyze the object and feature on the earth's surface. So mainly it collecting the imagery, and we can easily classify into land cover and other types of analysis using the remote sense data. So basically this is the basic definition about the remote sensing. Remote sensing is the science of obtaining the physical properties of an area without physical tasks. So without physical tasks, I want to just acquiring the information. And now how it will be work? So mainly it work on the sensor. Okay. Suppose what is the sensor? So mainly remote sensing uses the sensor to capture an image. Okay. In this time, suppose if you have a camera, you can simply take the photo using the camera. So in this time, we are also take the photo of the art, or we can take the image of the art. And remote sensing uses the sensor to capture an image. For example, in this time, we are using the aeroplane to get the image of the art, as well as the satellites, and also UAVs have the specialist platform that carry the sensor. Suppose satellites have a sensor, also drone have a sensor, camera have a sensor. So this type of sensor mainly uses to capture the image. And we can get the this type of sensor, you can see mainly satellite, we are also get the for balloon or drone or aircraft. So these type of things mainly have a sensor. This sensor used to capture the image for a specific properties or a specific landform. It create the image. And now types of sensor. So mainly we can get this type of types of sensor. So one is the drone. So you will suppose drone, then helicopter or airplane or low earth orbit satellites. So in this time, mainly we can get the three types of sensor, and it also some advantage and also some disadvantage. Here you can see. So mainly drone, this advantage is that you can get the very high resolution imagery. Suppose if you have a drone image, then we are also get the very high resolution imagery. Okay. And for that programmable flight path and lidar capabilities when you want to use the drone. And disadvantage is that very small coverage extent. So you mainly using the drone, you can get the result only for the specific boundary, very small boundary, not a big range of boundary, very small boundary. And visualize line of sight we can get from here. An airplane, what's happening airplane, you can see an airplane or helicopter. So mainly we can get the high resolution imagery and pilot flight path and lidar capabilities also. And disadvantage is that a small coverage, it can get the small coverage extent or a small area. We can take the photo only for the small area. Okay. But you can see here the low earth orbit satellites. So mainly it's very important because in this time we are use the all of those low earth orbit satellite imagery. Okay. Drone image or air helicopter image we are not using here, because in this time we are using the low earth orbit satellite. It can be Landsat, Sentinel, Modis. So this type of satellite we are considering this time. And this advantage is that we can get the high to coarse resolution imagery, large coverage extent. Okay. So basically using the satellite images, you can easily cover the large coverage extent area. And disadvantage is that mainly cloud abstraction. So mainly when you want to work with the satellite images, we can get the some cloud abstraction. We can get the some cloud or haze. But we also apply the different types of remotely sensed technique to remove this type of cloud or haze from the satellite images and get the very clear satellite images. Okay. Further, I also show you the practically how we can easily remove the cloud and get the very clear satellite images. And cover is limited to orbital path. So basically, low Earth orbit satellite image, we can get the it's covered the large coverage extent. Using the satellite images, we can easily get the for big region or big area. Suppose at the same time, we can get the information for the whole country boundary of Bangladesh or whole country boundary of India. At the same time, we can get from here. But drone or helicopter, this type of sensor only possible to for a specific field or very small region or a small area. Okay. And now image resolution. What is that? Image resolution is very important term. So basically image resolution, we can divide it into the total four types. One is the spectral, temporal, spatial, and radiometric. So I will explain one by one. So spectral, temporal, spatial, and radiometric. So these four types of resolution we can got. So first of all, what is the spectral resolution? Oh, sorry, spatial resolution. So mainly the spatial resolution specifies the pixel size of satellite images covering the Earth's surface. Pixel size. So spatial resolution mainly is the pixel size. Suppose here I can get the high spatial resolution, then I can get the pixel size is low. You can see pixel size 0.1 to 5 meter. It is the high resolution, or low spatial resolution when I can get the pixel size is high. Okay, 6 meter, then suppose 1000 meter. Suppose in this time we can consider, you can see the pixel size. So suppose in this time pixel, it's a 1 pixel. This pixel area is 30 meter. Okay, also you can say this pixel is the 5 meter, and also you can get the pixel is the 1 meter. So in this time, when the pixel size is low, then the resolution is high. Okay, so in this time the 1 meter, this resolution is better than 5 meter. 5 meter resolution is better than 30 meter pixel size. So when the pixel size is high, then resolution will be low, and when the pixel size is low, then resolution is high. Okay, so mainly resolution is the pixel size. So in this time, for the Landsat we are also get the 30 meters. So I'll show you the practically about that. So in this time you can just remember that resolution mainly it's depend on the pixel size. When I can get the pixel size is high, then I can get the low resolution. When the pixel size is low, then I can get the high resolution. So here you can see this is the quality about that. Suppose you can see the high spatial resolution. We can get the very clear satellite images for the high spatial resolution. All of those features we can easily identify from here. And we can get the medium spatial resolution. You can say I can get this type of image, and low spatial resolution I can get this type of image. Okay, so mainly low spatial resolution we can get the high pixel area. In this time this pixel size or pixel area is high. Medium is the pixel area is the medium, and high resolution is the pixel area is very small or small size pixel. Then we can get the high resolution imagery. So basically spatial resolution it's mainly depend on the pixel size. Then we talk about that. You can see about that another things for the mainly the Landsat imagery. So for the Landsat imagery, for the Landsat 8 imagery, we can get the pixel size is 30 meter. Okay, so 1 pixel for Landsat it covering the 900 square meter area. Okay, suppose Landsat 1 pixel, Landsat imagery for 1 pixel it covers the 900 square meter area. Suppose it's a 1 pixel, so this pixel covers on the ground 30 into 30 900 square meter area on the ground. Extract the information from here. And now spectral resolution. So mainly spectral resolution is the number and size of bands in the electromagnetic spectrum that remote sensing platform that can capture. So mainly in this time here you can see the, for example, the first two Landsat satellite use multispectral scanner, mainly MSS. It's a multispectral scanner, capture image using the 4 spectral band, green, red, and 2 near infrared band. On the other hand, hyperspectral platform, mainly it's the Hyperion. It's the one kind of platform can capture the hundreds of band on the electromagnetic spectrum. So mainly in this time, what is the spectral resolution? Spectral resolution is the number and size of band. So mainly in this time, for the multispectral or MSS, for the Landsat multispectral, capture images using 4 spectral band. Suppose green, red, and 2 in near infrared band. But when I talk about the hyperspectral mainly capture 100 of bands. So this is the difference between the hyperspectral and multispectral. So multispectral, you can see multispectral scanner mainly it captured the image 4 spectral band, but hyperspectral captured the hundreds of band. So that's why the hyperspectral remote sensing is better than multispectral remote sensing. Okay, further we'll already see a lot about the hyperspectral and multispectral. So here you can see mainly in this time you can see this the channel, mainly it's the band. Suppose this is the green band, red band, and near infrared band. Okay, so mainly this 3 band combination create this infrared. It's called the false color composite. So it's the multispectral. Okay, because in this time I just use it only for the 3 band combination, green, red, and near infrared. So green, red, near infrared create the multi-spectral. In this time, we can get the false color composite. So it's a multi-spectral. So now talk about the temporal resolution. What is the temporal resolution? Temporal resolution refers to the frequency at which imagery is recorded for a particular area. For example, Morris satellite capture the same area every 1 or 2 days, and Landsat satellite take the image of the same area every 16 days. So basically, suppose I have a one area. This area mainly, suppose I take the image for the 1st January for the first image, and second image I can got for the after 16 days. So it's a temporal resolution, and we can get the temporal resolution for the different satellite has a different time. Here you can see the Sentinel-1. We can get the temporal resolution for the 12 days. Okay, we can get the Sentinel-2 is that 10 days. Landsat 7, 16 days. Okay, on World View 3 is the 1 day. Tara is the 16 days. So basically, suppose it's represented about the frequency at which imagery is recorded for a particular area. For example, Landsat image capture the same area every 1 or 2 days. Landsat capture the same area every 16 days. Sentinel-2 capture the same area every 10 days. Sentinel-1 capture the same days after 12 days. So it's called the temporal resolution for single satellite imagery we can get. So it's a temporal resolution. And now we talk about the radiometric resolution. Mainly radiometric resolution is the sensitivity of a remote sensing platform to detect the slight difference in energy. So in this time we talk about the energy, electromagnetic energy. So and radiometric resolution is the measure in a bits, and the higher the number and the finer radiometric resolution. For the example, first Landsat set element is 6-bit radiometric resolution. However, Landsat 457 has the finer resolution of 8 bits. So in this time, types of orbit, because in this time we know about the types of orbit. So basically we can get the 3 types of orbit. One is the geostationary orbit, then sun synchronous orbit, and polar orbit. And we can see about this image from here. We can easily get the orbit. Suppose low Earth orbit, we can get, you can see types of remote sensing. So low in this time, it's suppose geostationary orbit. Mainly we can get from here this satellite imagery run from here orbit, and when you can see the when the distance will be far from the orbit, it take the more time. Okay, it take the more time. Suppose it take the low time for orbit for the whole around the world. Okay, and also low Earth orbit station, high Earth orbit station we can get from here. So in this time, types of remote sensing, we can get the 2 types of remote sensing. One is the passive remote sensing, and
So
one is
it means
yeah.
Sentinel is like the name of satellites, right?
No, it's the orbit name. Suppose low Earth orbit, high Earth orbit,
Orbit.
medium Earth orbit. Okay, geostationary orbit.
No,
So basically, this type orbit
I'm talking
satellite
about
image.
Sentinel.
Yeah,
Yes,
satellite image or
Sentinel.
satellite mainly orbiting this type of path. Okay, suppose some satellite image also orbiting the low Earth orbit
We have
station.
satellites.
Yes.
We have satellites, and then we have Sentinel.
Yeah.
Sentinel 1, Sentinel 2. No satellites. The
Yes.
satellites, I know, but the Sentinel, it's what? The Sentinel, because you show in the table that you show, I, s- I see
Yes.
that you have Sentinel 1, Sentinel 2,
Yes.
and then it's take the data after it's
Yes.
update
You can
the
see.
data after 10 days. Yes, here. Yeah, the mission, 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 Sentinel, Sentinel 1, Sentinel 2. In the mission, the column of mission, the column of mission.
Yes.
Yeah, you see the column of mission. Hello.
Yes. Can you hear me?
Yes, yes, here, this one, yeah, this one. What's it? Is it
So basically, it is
the
the
name of
orbit. Suppose in this time, for the Sentinel
okay.
1, suppose 12 days temporal resolution. suppose it capture an image for a specific place, but for the after 12 days it also take the image from here again.
Okay.
Okay.
Capture the. It's like the orbit. Yeah. Okay. This is the
Okay,
orbit.
can you any question
Okay.
please?
Yeah. It is. We have a difference between orbits and
Yes,
orbits, functional orbits and satellites.
you can see number of satellite. Basically sentinel one is a two satellite, sentinel is two satellite we can get from here, and it also
Okay.
orbiting the earth. Suppose this
Yeah. Yeah.
satellite image orbiting the earth 12 days, this satellite image sentinel to orbit the earth for the 10 days, Landsat 7 16 days.
So it means the satellite one is capture the data 12 days. 12 days. Yeah. Here.
Yes.
The resolution. Yeah. It's capture the data and the data. It's capture the data. The 12 days.
Yeah, so basically
Right.
the frequency, suppose it's a frequency at which
The
imagery recorded for
frequency.
a
Okay.
particular area. Suppose a
Okay.
specific area, it takes the 12 days
Okay.
for the frequency.
And
Suppose take the image, first image for the 1st January, and second image you can get the 12th January.
okay. It's like updates. It's
Yes,
12-day updates.
yes,
Each 12 day. Each 12 days.
yes.
Okay.
So basically it's the take the image, it's the interval. Suppose I take the first image on the 1st January, second image I can get the 12th January.
Okay.
This like
What is that? Okay. I
interval
got
we
it.
can get from here. Yeah. And mainly
Okay.
it's different. Suppose this you can see this temporal, suppose 12 days, 10 days, 16 days is different on the orbit. Okay, suppose
Orbit.
you can
Yeah.
see
Yeah.
this
Yeah. Yeah.
time
Yeah.
we
I
can
got it.
get the orbit look like that orbit. We can get that is you can this time you can see you can get the orbit for that low earth orbit, we can get the medium earth orbit, we can get the high earth orbit. Suppose low earth orbit, suppose any satellite image in here, they can easily orbiting the earth very short time. Then high earth orbit or medium earth orbit take the long time is need for the okay. But when I use any satellite
Okay.
image have the low earth orbit, it take the shortest time for that. So in this time it's called the we open find the weather communication or satellite in the high earth orbit, but the other satellite are open in the low earth orbit we can also get. So that's why it's this time variation, temporal resolution variation for the orbiting. Okay, so different orbit take the different time for the total world rounding. Okay, we can get from here.
Okay.
And now types of remote sensing, we can get the two types of remote sensing. One is the passive, another is the active. So first of all, what is the active? Active, the main difference between the active sensor is that its type of sensor eliminates its target. The active sensor measures the reflected light. Okay, so active sensor measures the reflected light. Suppose it is an active sensor, so active sensor mainly reflect the light on the earth and from here get the energy and store it in the earth. But passive sensor get reflected from the sun and store it in the sensor. Okay, but active sensor mainly it provide the light on the earth and from here get the energy and store it in the sensor. But passive sensor get the light from the sun and it reflected and stored in the sensor. So basically it's the common things about the active and passive. So passive sensor measures the reflected light emitted from the sun, and when the sunlight reflect off the earth's surface, passive sensor capture the light. For example, Landsat, Sentinel are passive sensor. Okay, because Landsat, Sentinel are passive sensor, they capture image by sensing reflected sunlight in the electromagnetic spectrum. So Landsat, Sentinel, this type of passive sensors. But suppose LiDAR is a active sensor because LiDAR mainly provide the energy and then come and then reflect the energy and go to the sensor. But in this time, it reflected the energy from the sun and stored it in this sensor from here. So it's the passive and it's the active sensor. And active sensor, mainly passive sensor, it can be Landsat, Sentinel, Modis, it is a passive sensor. And active sensor mainly LiDAR. Okay, this type of things we can use for the LiDAR. In this step, it's very important for the electromagnetic spectrum. Okay, the electromagnetic spectrum mainly you can see it's called the electromagnetic spectrum. It will be range from short wave infrared band and short wavelength to long wavelength. So mainly X-ray to microwave. Okay, this is the length about that, and we can only visualize our human eye only visible for the spectrum. Okay, visible spectrum. This range mainly 390 to 700 nanometer. Okay, suppose this is the visible range. We can get the visible range from here. And here you can see the one example about that for mainly this example for the NDVI. So mainly green, this is the green, it infrared absorb the infrared and reflected, you can see 50% about that near infrared, and visible we can get the 8%. Okay, so from here we can get about that, you can see the normalized difference between that 0.72. Okay, and also you can see for the near infrared we can get these same things. So in this time for the near infrared, it is very important. Near infrared is the observed. Suppose green color or green vegetation observe the near infrared mass, very mass. But you can see this time it is another color. Okay, so that's why you can get the low vegetation. Okay, so in this time it observed the near infrared only for the 40%, and in this case it observed the near infrared 50%. So that's why in this time we can get the better vegetation range 0.7, and we can get that only for the 0.14 because it reflected the near infrared energy is very low, only for the 40%. Okay, so further we talk about the lot of things about the practical example about the remote sensing work, mainly NDVI, how it will be worked. Okay, any question?
In this case, what is a good
Mainly vegetation reflected more green light. Okay, suppose vegetation mainly reflected more green light, so that's why it reflected the 50%, and it's not a green, you can see it's not a green, it's another color, so that's why it reflected only for the 40%. Okay, this near infrared band. So now we talk about the spectral bands. What is the spectral bands? Spectral bands, mainly we can get the two types of spectral bands. One is the multispectral, another is that hyperspectral. Okay, so multispectral and hyperspectral. So now we talk about the multispectral. So what is the multispectral? Multispectral mainly you can see, mainly we can get the RGB color, red, green and blue. But when I want to divide it more band, okay, more band, then it's called the multispectral. And suppose hyperspectral, more than 100 bands we get from the hyperspectral. And for the Landsat, you can see here, okay, the main difference between the multispectral and hyperspectral is the number bands and how narrow the bands are. And hyperspectral have hundreds of narrow band. Okay, and multispectral image consists 3 to 10 wider bands. So multispectral has 3 to 10 wider bands, but hyperspectral have a hundreds of narrow band. Create the hyperspectral. So in this time multispectral, here you can see multispectral imagery generally refers to the 3 to 10 bands, and here you can see mainly this band for the Landsat imagery. We can get this type of band, such as coastal aerosol, blue, green, red, near infrared, short wave infrared to panchromatic, cirrus, thermal infrared 2. So basically this type of band we can get the multispectral for Landsat imagery. Okay, for the Landsat imagery we can get this type of band. And hyperspectral mainly imagery how much narrow bands are. Okay, so has a lot of narrow bands, and the hyperspectral image has the hundreds of thousands of bands, narrow bands. So here you can see it also divided with more narrow band. Okay, and the number of narrow band will be hundreds of thousand bands created. It's the hyperspectral remote sensing. technique. Okay, so this is a reference about that. So in this time we talk about that how we can easily download the Landsat, Sentinel, or any satellite imagery, how we can easily download from. So first of all, here you can see this is the one kind of link. So mainly using this link you can easily download the Landsat image. Using this link we can easily download the Sentinel image. Using this link we can easily download the DEM data. Okay, so let's go about that. Not only for that, it has also other source also is available. Suppose I will show you the practically. So just I simply suppose open a website. Suppose Sentinel one. So just I will simply search. You can see Copernicus. I simply search Site Hub Copernicus. I simply search on the Google. So now it show about you can see Copernicus Open Access Hub. So click on here. From here I can easily download the images. So for that I just simply you can see the Open Hub. Okay, access to all Sentinel mission data through the interactive graphical user interface. So simply click on here. So okay, so now it show about that. Okay, so now simply go to this link. And further in this time, you can simply can see the Explore Copernicus browser. So just click on here, Copernicus browser. So now it open a window, and from this window, we can easily download the Sentinel-2 satellite imagery or Sentinel-1 satellite imagery for whole world and use it for our remote sensing work. Okay, it working. Okay, I think some networking issue. Yeah. As well as you can also try to suppose this link for that Landsat. Just I simply copy. As Earth Explorer. So in this time, from this window, you can just simply download your satellite images. So first of all, here you can see the option search criteria. So mainly in this time, you can simply select your feature or path and row. So I simply put the first one. And suppose, and further, I just simply go to here and you can see the your about that. Suppose all. And further, you can simply select your feature type. Okay, so in this time, I want to US feature and world feature. Okay, so in this time from here you can simply select your country. As Bangladesh, I simply select. You can see the vegetation function. Okay, so admission boundary feature all, and also you can see the data set. So in this time from here you can simply select your data, which data you want to need. You can see in this time we can get a lot of satellite imagery. You can see aerial imagery, also you can see commercial satellite image, digital elevation. We can easily get from the different types of digital elevation data set as remote distance data. Also we can get from here the Landsat. You can see, yeah, you can see the Landsat imagery. So click on here. Here you can see the Landsat image collection from here. Yes, so here you can see the Landsat level 2.1 data set. Okay, we can easily get from all of those data. You can see Landsat 8.9. Okay, suppose select on here, and further you can see here. Okay, so further you can simply go to the off additional criteria, you can simply set. So you can see now it loaded about that, and further you can simply put here a specific path and row from here. You can see, so suppose you can put the path and row in here. Also you can see the row put in here. Also you can just satellite. So in this time you can simply take which satellite 9 or 8. Suppose I need the Landsat 8, so select the Landsat 8. And further if you want you can simply put here other information, such as you can see the data product. You can simply put your time period, a specific time period. Okay, so further you can see the image quality about that, and all of those things you also need to mention about that. You need to log in. Okay, so first you need to log in. So click on the login, and if you have no account, suppose you have no account in this here. So in this time you can see this is my account. I already created this account. So then you can simply click on the create a new account. Okay, for getting the satellite image from here. So you can see the create account. Click on here and put all of this information. You can put the username, new password, confirm password. I am not robot. Then continue, and further you are just need to the verification. They send you the email on your Gmail which you put in here. From here you can easily successfully log in. Okay, after login you can download the satellite image from here. Sorry, from the Landsat. And for Sentinel we have to use this website. So this is the Sentinel. And Sentinel, you can also see the login option. So just you can simply log in from here. So I just log in. Okay, just log in. And if you have no account about this Copernicus browser, simply registration with your account. Okay, so you can see I already just click the login. So you can see now it login. In next time it show my name. So now from here I simply search my data. Suppose which data you want to need. Suppose Sentinel 1, Sentinel 2, Sentinel 3. Suppose I need the Sentinel 2. So click on here. And I need the level 2A dataset. So click on here. And cloud, I need the suppose low cloud or 0% cloud I need. And further I just simply filter about this specific time. You can see you can put your start date and end date, and simply you can simply select your study area. Suppose in this time I simply select my study area. Suppose okay, it's loaded. Yeah, suppose I select my study area. Suppose this is my study area. I simply focus my study area. And further I simply draw a, you can see we can easily draw the our line, or we can easily draw the lines, or you can see the draw the intersect. So simply click on here. Or take the point. Suppose I set the marker in here. Suppose this point I need this image. So just further I simply search. So now it's searching. It takes a time for doing that. Okay, so no product were found. That's parameters. Okay, so in this time I just try to take the rectangle. is my study area. Okay, just like, and then further I just simply put this time. Suppose from here 2000, and now search. Or another you can also try to apply. So if you have the suppose Google Earth Engine account, so from here you can easily download all of those data, Lancet, Sentinel, Moody's, or any kinds of remote sensing data. We can easily also download from the this Google Earth Engine platform. Okay, and it is very easy way. We can download it from here, because you can see from the browse data catalog. We can easily suppose click on here. Now it open all of those Lancet, Moody's, Sentinel. So all of those data, so you can easily access from here. Not only for that, also you can get the surface temperature data, climate data, atmospheric data, weather data. Also you can see the different types of imagery, Lancet, Sentinel, Moody's, high resolution imagery, geophysical data set, terrain data set, land cover data set. So a lot of data, so you can easily access from here. Suppose you can see the Lancet. It takes 6 minutes. Okay. So now I talk you the another thing is that I already download a imagery. So further in this time I want to use it and show you the example. But previous I show you that how we can download. Okay, when I show you that. So here you can see this is the image. Okay. So this image contains total 6 band. Okay. Mainly B1, B2, B3, B4, B5, B6. Okay. The total 6 band is available in here. So further, I want to make the analysis using this band. Suppose I want to make a vegetation cover map. Okay, so mainly NDVI. Okay, so vegetation cover map is the NDVI, and you can simply search on the Google. Suppose I simply search here. What is the formula about the NDVI formula? NDVI formula. So mainly NDVI formula is that you can see for the Lancet 8, we can get the band 5 minus band 4 divided by band 5 plus band 4. This formula is for Lancet 8 and 9. We can get the formula near infrared minus red divided by near infrared plus red. So in this time, I want to make the NDVI using this band. So here I already available for the near infrared B5, and also available for the red, which is band 4. Okay, mainly band 5 and band 4 I need. So band 5 minus band 4 divided by band 5 plus band 4. Then I can make the vegetation cover map from this study area. So very easy. You can simply go to the catalog. From here you can open your special analytics toolbox. Here you can see system toolbox. I simply click on here, and from here find out the special analytics. You can see a special analyst toolbox, and from here we can find out a option. It's called the, you can see the okay, so this is that column. So math, it's called the distance. Okay, groundwater interpolation, raster creation, not or okay. Oh, you can simply search here. Suppose I simply search here toolbox. Suppose raster. Okay. Raster calculation. I simply search raster calculation. Looking at the raster calculator, you can see this is the tool raster calculator. In this time I want to use it. So basically, okay, so we can get the map algebra. Okay, so you can see a special analytics tool, go to the map algebra, and from you can get the raster calculator. So double click on here, raster calculator. In this time, I first of all I just take a okay. So in this time we can take here, calculate these things. Just take the float, okay, and put the equation b5 minus you can see these things from I can see near b5, okay, b5, and then put here the minus sign, so minus, then b5 minus b4, you can see the b4, double click, okay, then put here the divide sign, you can see the divide, and further you can click on the float, okay, then put here the b5 plus b4, here is the b5, then you can see the plus, put here the b4, okay, just put this equation, and I want to save it the default, click to the OK. So now it make a new layer which calculated the vegetation cover. It working. Okay, so okay, it's done, you can see. So in this time I can get the NDVI map from here, you can see I simply uncheck all of those others band. In this time it not need, I'm simply uncheck. So here you can see I can get the map, this variable, and I simply zoom to layer, so I can get this type of things. So it's a high NDVI value 0.8, low is that. So I just simply click on here and go to the symbology. I set the color. Suppose I show the color high, show for the vegetation red green color. So I showed this color and apply and okay. So now I can get this type of map from here. So it's the NDVI map. Yes, I can find out vegetation cover. So just okay. And in this time, suppose I want to just do import my shape file. Suppose this boundary shape file I simply import, such as then make the proper map of NDVI. So just simply go to my shape file folder. So just I simply import shape file. So basically it's a big region. Here you can see my boundary. Just I try to increase the size of the width. Okay, so as you can see, this is the boundary. Or if you want, you can also make the big boundary, no problem. Suppose I just make it NDVI for this specific boundary. Okay, so this boundary I want to, suppose this is my study area. Okay, this is my study area. So just I simply click on the lasso tool. You can see the lasso tool, and then click on this map. Okay, it's selected. You can see selected. Further, just click on here. You can see the data, export data. I click in here, and then okay, and I don't want to save it. So you can see in this time. Okay, I uncheck it. It's not need for this time. I'll remove it. It's not need time. In this time, I can get my study area. So this is my study area boundary. Okay, this is my study area boundary, and I want to already created my NDVI map. Okay, so in this time, you can see this is my boundary. Red color NDVI about the boundary. So in this time, I just simply extract by marks. So for that, simply go to the catalog, and here you find out a option, special analytics tool. You can see special analytics tool, and you can get the extraction, and click on the extract by marks, and you can see in this time input raster. So mainly this is your NDVI map, and input feature mainly boundary. So this is the boundary. You can see export output 7. This is my boundary name. Simply click on here and then okay. So now it make the boundary of NDVI map. You can see. Okay, it's done. So further I uncheck it. So now I can get this map only for my study area, which I choose in here. So further I simply click on here and I want to add here the color plated. Suppose this type color plated, or if you want you can simply go to the symbology. Suppose go to the click on here and go to the symbology, and further you can simply use here the different types of things. Suppose okay, just I use here this color, apply, and okay. So now we can get the vegetation, and it's the water body. Okay, this type of the water body, or you can get this type of the vegetation from here. So in this time, okay, just I want to use here this yellow color, it's better. Okay, so now you can get this type of NDVI map, and if you want you can also just click on here. Suppose you can see the one, you can say identify, click on the identify and click on here. Suppose this type of pixel, you can get the negative value. You can see we can get the NDVI value for this things is that we can get from here. Or suppose also click okay. So in this time uncheck it, this boundary. So now click on here, we can get the, you can see pixel value is a negative. Okay, for the negative pixel will identify for water body. So click on here, I can get negative. Suppose for the green pixel, you can see green. Here I can get the vegetation 0.4. It's a positive value, and negative pixel will identify about the water body. You can get the 0.016. Okay, also you can see click on here 0.2. Okay, so it's the vegetation, and negative will identify about the water body. From here you can click it.
What is the I mean what is the purpose of this?
So basically this
Of
map we are represented the vegetation cover, mainly
the
vegetation.
purpose of download and import.
Yes, so I will show you the again for the downloading, because in this time this image I already downloaded. Okay, so but the process for making the NDVI map is the same. When you want to download the image, just apply the same approach. Okay, so my downloading is also going on. Just a minute, I check what is the status about the downloading. You can see it's also going on. So after downloading this, we are just also applied. Okay, it's done. You can see. So further, I just simply click on here and open in Drive. Here you can see. Yeah, you can see we can get this image. So now click on the download. Okay, you can see downloaded. Loading. Okay, it started downloading. Okay, you can see it started the downloading. So from here we can easily download the image. So I again explain the downloading code. First of all, in this time, this is my study area. You can see this is my study area. Suppose Dhaka city. Okay, Dhaka city is my study area. So I want to download the satellite image for the Dhaka city. Okay, so first of all I need to import the Dhaka city shapefile in my Earth Engine platform. So how I can do that? Simply you can go to the asset tab and click on the new button. Here you can see the SSP file, shapefile. So click on here and then go to the source file about your shapefile, and then further you can simply import your shapefile. Suppose suppose in this time your shapefile is that. I simply show you that. Suppose this is your shapefile. Simply select SSP, DBF, PRJ, and SSX. Okay, these four files simply select any kind of shape analysis. Such as one kind of analysis, I will show you that for NDVI. Suppose we can see, we are just make the map for this study area for NDVI. Okay, and from here you can easily identify about the vegetation or other things. You can easily get the and also create this type of map from here. Okay, so in this time, suppose you also make the classification. For downloading satellite image, I will show you the later about the proper way for downloading the satellite image. Okay, so then classified, you can see classified, and you can easily make the classified. Suppose I just make the classified total. Suppose you can put the class, suppose three class you can put, and you can just classify it. Suppose I just classified it's a water, and put here the suppose it's a mainly land, and put here suppose it's a suppose vegetation. Okay, and put here the water suppose as a I put the color as a blue color. Land I simply show as a this type of yellow color. I show as a green color. And then apply and okay. Okay. So now we can easily get this type of things. You can see water body. It's a water body. It's a vegetation. Okay, and it's only for the barren land. Okay, it's called the barren land. You can just make the classification water, land, vegetation. Or if you want, you can also put here the suppose 4 class. Suppose I take the another class 4 class, and now you want to define about that. Suppose it's a water. Suppose it's a water, negative pixel value, and it's a I just simply put here that it's a land or barren land or fallow land. It's a low vegetation. Mainly we put here the shrub, and it's put about that suppose dense vegetation. Dense vegetation. Okay, and further you can simply put here the water body as a put here that this type of blue color, and then blend I want to show as a this type of suppose gray color, and shrub I want to show this type of light green, and dense I want to show the this type of green. Okay, then apply and okay. So now we can get about this type of things. You can see we can get from here. So it's identify this type of color, identify about the dense vegetation, and it's identify about that your barren land or your only for land, and this type of identify about that vegetation. Okay, so I think it also used for the yellow color is better for that. So just click on here, go to the properties, and I simply change the color. Suppose this color and put this type of yellow color, so better visualize about. So now you can get type of things you can see. So now we can easily get the idea about that. What is that? Vegetation, shrub, we can easily put in here. Okay. So this is the process for using the vegetation map and also make the vegetation cover map. And further, you can simply click on the layout view and add all of those necessary elements and make the map. Suppose I just simply increase this size, or I can also increase this size. And further, I just make a map of vegetation cover. So for that, I just simply add the legend. So click on here, you can see the legend. Click on here, the legend. And I want to legend for this map, and then next, next, next. Okay, then finish. So now it create the legend about the water, land, and shrub and dense vegetation. We can create the land, you can see. And in this time, this type of things I want to remove. So for that, click on here, and you can see the convert to graphics. Click on here, and further you can simply remove. You can see the ungroup it, and then remove that value, and also remove that value. So now call the legend, put in here properly, and then set all of those things again, and then simply make it the group. Okay, then simply increase it size. Okay, then further you are just make a title. So just put on the insert, and you can say the title. I put this title is that suppose vegetation cover map. Then okay, and also increase the size. So then go to the send symbol and increase suppose 24. Okay, then okay, and apply and okay. Then vegetation cover, and put here that your scale. So just click on here, insert, and here you can see the north arrow. So I add the north arrow. So then put the proper place about that north arrow. And let's put the scale. Suppose just simply click on the insert. And here you can see the scale bar. Okay, just select and hit to the scale and go to the properties. I want to show the is that about square kilometer unit. Apply and okay. And okay. So and further I want to add in here. So further you can simply add here the suppose click on here layers and go to the your properties. You can get the grid. Click on the new grid. So then next labels only. Next I take only for the major division ticks. So next. Okay, then go to the properties and then set the some option about the grid. So I want to size increase suppose 10, vertical left and right. Okay, then lines it's okay, intervals okay, axis inside, ticks inside. Okay, then further apply and okay, also apply and okay. So now it also generating this type of grid. You can see latitude and longitude about that value. Just a simply proper place about that. Also increase it. Also increase it. So further you can save this map. Okay. And then further you can simply if you want you can also add it to the base map. Check okay, not active now. So then simply save it. Suppose export map. And I simply put this map name suppose vegetation map. And further save it in the desktop. So set the JPG format and then save it. So now it's create the vegetation cover map for this study area. So here you can see. Yeah, this is our map. So I can see it represented the vegetation cover map, and from where you can really get the idea about our water body, land, shrub, and dense vegetation, as well as if you can also calculate the area. So further course I will show you that. In the meantime, you also try to first of all you need to download the satellite images. Okay, so in this time you are just make a account this website. Okay, so Earth Explorer USGS website you try to make a account. Okay, using all of this information. Simply go to this website and then put all of this information and try to open a account. Okay, so it's very easy. You can simply put all of your information. So this website you can put all of this information and put your password. Okay, then try to open a registration in your account, as well as also Copernicus. So this website you also try to make a account for getting the Sentinel-1 Sentinel-2 satellite imagery. Okay, so basically these two things we need for this website Copernicus. And I also check the problem for the Google Earth Engine code. What's the problem and how we can get the better. So in the meantime, you also try to make the account on the Earth Explorer, this website, and also try to make the account on this website. Okay, for the Copernicus, try to open this account successfully. Okay, then further you can easily download the satellite images easily from here also. Okay. Okay. Any question, please? Okay, can you hear me?
Yes, but yeah, I can hear you, but I didn't understand very well the purpose of this, because before to do anything, we need to know what we need exactly, and basically to that you can go to download the data or to do anything.
Yes.
So,
So
but for me,
in this time
yeah, yeah, yeah.
you try to download this. I can just make this account. Okay, first of all you try to make this account in this account website, and also try to make this
Because
account in this website.
we are using this account, and we are using also the Google Health, the Google Health
Okay,
engine.
In this time I use this
I'm
account
confused. The data
and
that the data that
download these
we
images.
download is
Okay,
from this one or from yeah.
okay, this image
Please go ahead.
yeah, this image I download from this website. Okay, this website, not Google Earth Engine. So in this time you also try to open the registration with this account. Okay, because further class we also need the more satellite images for the different region. So for that you need to download this satellite image first. And how we can download the proper satellite images? For that